Hello there guys, welcome back to another epic inexorable maths video. In this video we have got 3 more questions using the comparison test to determine whether a series converges or diverges. So we've already seen the comparison test before. I will leave all the relevant links in the description. Let's just go straight into question number 1. Determine whether the sum from r equals 3 to infinity of the square root of r over r minus 2 converges or diverges. So what do we think about that? And again, we want to use the comparison test. The comparison test, the idea behind it is to see if we can rewrite this sum as being either bigger or smaller than something that is easier to determine whether that converges or diverges. So for instance, what we can say is that the sum from r equals 3 to infinity of the square root of r divided by r minus 2, well, we can say, because we have an r minus 2 here, it might be nice if that was just an r, not r minus 2. So if you take 2 off of a number, you make it smaller, of course. Especially if, if it's positive, you're making it smaller. When you divide by something smaller, it's bigger, okay? So this, when we actually replace, we want to replace it with the sum from r equals 3 to infinity of just the square root of r over r, will this be bigger or smaller than the original thing? Well, again, the denominator here is smaller, so the original will be bigger. So this is bigger than this. Hopefully that makes sense. And the idea behind why we did that is because what we can now do is just slightly rearrange that to write it as the sum from r equals 3 to infinity of, well, the square root of r over r is the same thing as 1 over the square root of r. In other words, 1 over r to the power of a half. And then we can use the p test to determine that this diverges, okay? So this diverges, okay, it diverges by the p test. And remember, the p test basically says the sum from r equals any constant to infinity of 1 over r to the power of, let's say, p, will diverge if p is 1 or less. And, well, a half is less than 1, so it diverges. But this is bigger than this. So this is bigger than something that's basically equal to infinity. Therefore, the original thing also diverges. Okay, hopefully that makes sense. Okay, on to the second one. Okay, here's the second one. So now we want to determine whether the sum from k equals 1 to infinity of cos to the 6 of pi over k all over 6 to the k diverges or converges. Once again, we're going to use the comparison test. So we want to simplify this and then do basically another test on something simpler, which will help us determine what we can do with this. But when we simplify it, it doesn't have to be exactly equal to it. It could be bigger than or less than, depending on what we're trying to do. So I'm looking at the thing that's probably the most complicated in this, which is the whole cos thing. So cos to the 6 of pi over k. That is just very difficult to work with. Now, the thing is about cos to the 6 is that cos of anything will only take values between -1 and 1. But when you raise it to the power of 6, it will only take values between 0 and 1, okay? Because when you raise something to the power of 6, you are squaring it, which makes it only positive, and then you're cubing it, but that doesn't really do much once it's already positive. And because cos is only between 0, or -1 and 1, I should say, when you raise it to the power of 6, it's basically only going to be between 0 and 1, okay? So hopefully that makes sense, that logic. Basically what I'm saying is, this is always less than or equal to 1. So what I'm going to do is I'm going to realize, I'm going to write everything down just so you can see it really clearly. I'm going to notice that cos to the 6 of anything, but including pi over k, okay, this is always going to be less than or equal to the number 1. And technically bigger than 0 as well, I should say, but that doesn't really matter for this part of the question. It's always less than or equal to 1. That is the important thing. Okay, cool. Now, what I can then do is say, therefore, the sum from we're using k now, so k equals 1 to infinity of cos to the 6 of pi over k divided by 6 to the k. This has to be less than the sum from k equals 1 to infinity of just 1 over 6 to the k. Just so you can see what I've done there. Hopefully that makes perfect sense. Again, because this is always less than or equal to 1, then the sum of all these terms would have to be less than 1. Okay, cool. And now, guys, what's this? Now, you might say, oh, we can use the p-test for this, but actually we can't use the p-test because it's not in the form k to the n. It's kind of in the form like n to the k, or it's not k to the p, it's p to the k, if you want to put it that way. We can't use the ratio test, or we can't use the p-test for this, sorry. We haven't done the ratio test yet. We can't do that. So how do we do this? Well, guys, notice that this is actually just a geometric series, okay? It's a geometric series because this, if I was to write out the first few terms, it would be 1 over 6 to the 1, so just 1 over 6, plus 1 over 6 to the 2, so 1 over 36, plus 1 over 6 to the 3, which if you know what 6 cubed is, it's 1 over, that'll be 216, and so on and so forth, right? And it goes to infinity. So there's actually a formula for this. There's actually a formula that says that the sum to infinity for a geometric series is the first term in the series divided by 1 minus the common ratio. Okay, this is for a geometric series. Well, let's just do that. So the first term, u1, would be a sixth. And then we do 1 minus the common ratio, which is 1/6. Obviously, for this to work, the common ratio would have to be less than 1. Okay. If I times the top and the bottom of this fraction by 6, I would get 1 over 6 minus 1, which is 1 over 5. Okay. Now, we're saying that this is less than that. So this is less than 1/5. What we're looking for is less than 1/5. This is less than 1/5. So does it converge or does it diverge? Well, it converges because it is smaller than a finite number. So this one converges. Nice. So we're turning something that looks very complicated into something simpler, and then we're doing the convergence test. Cool, let's look at the very last one. Okay, here is the third and final question that we're going to do in this video. Determine whether the sum from n equals 1 to infinity of n plus 1 to the n divided by n to the n plus 1 diverges or converges. Okay, so this one might look a little bit tough, like, where do I start? Where do I start? Well, let's think about this, guys. N plus 1, slightly more complicated than just n. So maybe let's try and get the n plus 1 into an n. And then you can see that a bunch of stuff will just cancel out, right? So let's have a look at this for a second. Do you agree that n plus 1 to the n is always bigger than n to the n? I would as well. So that means that n plus 1 to the n divided by n to the n plus 1 would also be always bigger than n to the n divided by n to the n plus 1. I've just divided both sides by the same number, so it couldn't possibly change the inequality, right? So this is always bigger than this, which means that the sum of this will be bigger than the sum of this. That's the idea. So what I'm going to do is I'm going to rewrite this series as the sum from n equals 1 to infinity of n plus 1 to the n over n to the n plus 1, and I'm going to say that this is always bigger than the sum from n equals 1 to infinity of n to the n over n to the n plus 1, okay? That's all I have done. I've just replaced the n plus 1 with an n, thereby making it smaller, so I've said that. Okay. Now, the reason why I've done this is because now this is just going to simplify it very nicely, and it won't be too difficult at all. So obviously we have n to the n, we have n to the n times n to the 1, just to be really clear on this step here that I'm about to do. N to the power of n plus 1 is n to the power of n multiplied by n to the power of 1, okay? And then the idea is I'm just going to cancel this and this out, and I'm just going to have the sum from n equals 1 to infinity of just 1 over n, okay? And guys, by the p-test, once again, this diverges because p is 1. And if p is 1, it still diverges. So by the p-test, link in description to the p-test video, by the way, if you want to see that, this diverges. But here's the kicker. We said that the original thing over here is bigger than this. This is bigger than something divergent, which means that this also diverges because it is bigger than infinity, so it's also infinity. Boom, there we go. So there's 3 questions using the comparison test once again. So now we're going to move on to the ratio test, which is the next thing, or in particular, one version of the ratio test, the most normal one. We're going to move on to that. So in the next video on convergence test, we'll be looking at the ratio test. The ratio test is probably the most normal one, the easiest one to do, I guess. Maybe the funnest. We will see. The p-test is the easiest, I would say, but the ratio test is pretty cool. So I will see you guys in the next video. Thank you all so much for watching, as always, and I'll see you then.